we'll be starting. Hello, everyone. My name is Archita, and I am a PMRF scholar at ICER Kolkata. I am your second TA for the course Air Pollution and Control. I'll be taking sessions on Monday. Now, we were told that we are not supposed to tell you the assignment questions. On the other hand, what we can do is that we can find questions from the lectures for each week, and we can help you understand uh, each question sorry, okay, we can help you understand the week material better. Okay, I hope the screen is visible to everyone. So there are some questions that I have decided on that I'll be talking about. So, okay, so now let's move ahead. So, this is for first question. So, if we look at the 5 lecture series for week 1, we'll see that the starting is from the how the air pollution begin. Okay, that how what type of fuel we used to use during the pre-industrial times and how it changes during the industrial times. Then we see that what are the acts and the protocols that are designed for the management of air pollution, and what are the major events that are drastic events of air pollution that happen in the around the world as well as in India. Okay, then we move towards their how the layers of atmosphere are, what are their effects on plants, on animals, on humans, as well as on the structures that we see in the around us. Okay, so my first question that I choose is that how the fuel use changes from the pre-industrial towards the industrial time. Okay. Uh, Right. So we know that during the pre-industrial times, it is the time of the Neanderthals or the ancient men, and that time we know that initial the fire is started from the stones, and then the use of wood increases, and then the use of coal increases, and it moves towards the oil and in the present times, along with currently, because pollution is so much that we are moving towards the use of environmental friendly fuels. Okay, so what happened is initially relied on wood to during the pre-industrial times. When the industrialization or when the population start increasing, the consumption of wood increases, and hence the wood become very scarce. The forest, there is a lot of deforestation, and then we move towards coal. Okay, and now we know that the first railway started from steam engine and all of that, and currently we use oil as well as other petroleum products during the industrial times. Okay, now when it comes to air pollution legislation, we cannot remember all of them. There is an overall legislation that is applicable to all the countries, and there is legislation that is particular for each country, right? So these legislation, so next question is that of all the legislation that are there about the air pollution and its management, what are the important ones which we should remember? Okay, so two of them are, first is the Air Prevention and Control Act. Okay, which is formulated in 1981, and later it was modified, and still, modification keeps on happening every few years. And second is the Environmental Protection Act, which is 1986. These two are very important acts, or the rules which actually are mandatory for to manage the air pollution in India. Okay. Now, in the lectures, you see that there are many drastic pollution events that have been discussed. Now, there are some which happened across the globe. For example, London smoke, New York smoke. Okay, but there are some which happens in India, and which actually cause lot of people, like death of a large number of people, as well as animals. So one of the major, which is being discussed multiple times, and which is one of the most drastic event, is Bhopal gas tragedy, which happens in 1984. Now this is one of the event in which, because of the leakage of methyl isocyanate, so this is the structure of methyl isocyanate. Okay, so because of the release of such harmful chemical, and this methyl isocyanate, the property is that it can react with water vapor, okay, with water, and can leads to release of CO2, which is a very very harmful gas if you inhale it. Okay, so in this Bhopal gas tragedy, there are about 4,000 people died because of the poisoning of methyl isocyanate. It leads to the formation of CO2 in a body, which is very harmful. And a very recent example, if you see, which is discussed in the lectures, is about the Vizag gas leak of 2020. It is because of styrene vapor. So styrene, I have pasted this picture. It's nothing but uh, vinyl, or you can say ethyl benzene, and these vapors are also harmful, and actually lead to hundreds of death of hundreds of people. Okay, now okay, just okay. Now we move towards, so the other questions. So next question is, how do temperature and pressure changes in the atmosphere layer? So we know that there are okay, so there are, so this is a picture for that. There are different atmospheric layer: troposphere, stratosphere, stratopause, mesosphere, and thermosphere. And their boundaries are tropopause, stratopause, mesopause, right? So when it comes to temperature, when it comes to pressure, the pressure change uh, like this blue line is pressure, that uh, it is high at the surface, and it decreases towards the altitude, towards the higher altitude. Now the reason for this uh, decrease in pressure with altitude is because when, as you go up with altitude, the density of gases decreases, and as this density decreases, the air become lighter and lighter, right? So as you go up, we see lighter air, and so if anything has to come, let's say, from the top towards the bottom, the least pressure, it, where it will feel the least pressure, it will feel the least or the lowest pressure towards the top, because the air is lighter, there is less friction, right? And as the air become denser towards the surface, the pressure increases and it feels heavier. Okay, next is temperature. Now temperature is very different compared to pressure, because it does not linearly decreases with altitude. It increases, decreases, increases, decreases among different layers. Now when it comes to tropopause, the temperature decreases with height. Now the reason of this is, let's say we know that we are okay, so we are getting influx of air, influx of solar energy. Okay, so when you have influx of solar radiation, then the ground is uh, and the okay, and the earth, what earth is doing, that whatever energy the earth can absorb, it absorb. Whatever is left, it emit back. Okay, so there is also outflux of solar radiation. Now, because we are, whatever is coming, we are also transmitting back. So the air near the surface of the earth, which is this, is uh, is have higher temperature. But as the air moves away from the earth in the tropopause, okay, as it also become less denser, then this uh, outflux solar radiation also decreases, and hence the temperature decreases linearly till the tropopause. Now it's almost stable in the ozone, and again start increases in the stratosphere. Now in the stratosphere, even though this is lighter, but what is happening is that the UV radiations are coming, right? And this ozone is absorbing these UV radiation. So till here, the ozone is absorbing the UV radiation, but before this, there is no. After this, it's absorbing. But till here, there is UV radiation, which is because of the influx of solar radiation. Hence, the temperature increase linearly in the stratosphere. And same uh, in the mesosphere, it is stable and then again start decreasing. Uh, because of the thinness of the air. Okay, so the because okay, another reason that it start decreasing is that particles are very lighter air, and hence less what you call less friction or less collision. So when the particles are not even coming close to each other, there is no thermal transfer, right? There is no transfer of heat between two particles. And hence, even if there is radiations here, they are not transmitting from one particle to another, and hence the temperature decreases. Okay, so this is the phenomena of temperature increase and decrease. Now, another question is about the source and sink relationship of air pollutant. Okay, so we know that whenever we are talking about air pollution, there is whenever we are talking about air pollution, there is a way in which the pollutants are generating, and there is a way in which these pollutants are getting deposited or are getting reduced or extinct from the atmosphere, let's say. Okay, so when it comes to sources, we know that these gases or these particulate matters, for example, so we know in the atmosphere we have SO2, NO2, and these ozone and the particulate matter, carbon monoxide, carbon dioxide, all of these gases, they can be either primarily formed. Now when it comes to primary formation, yeah, primary emission, it comes directly from the source. Okay, for example, vehicular emission, or for example, emission from factories or forest fires. Because what is happening is that there directly something is happening in nature, and it is releasing the particles in the form of what particle. Okay, so this formation is directly particles. Another is secondary emission is when emission is in the form of gases, or what we call as VOCs, which is volatile organic component, yeah, compounds. Okay, these are released from the plants. Okay, VOCs are also released from anthropogenic sources or man-made sources like paints. Okay, so these gases and VOCs, they release from the plants or from paints or whatever, and they directly cannot deposit, and they can further convert into particle. Okay, So the emission can be directly in the form of particle or can in the form of gases which convert into particles, right? So this emission or the sources can depend on the different type, rate, configuration, etc. And then when it comes to the atmosphere, there are different phenomena that can happen to the to a particular compounds or a component. Okay, so for example, dispersion can happen. Dispersion is that when a particle is released, how far it can reach. Okay, so dispersion, again, it will depend on the size of the particle, right? A larger particle will reach like near to the source or will affect the people or the flora and fauna near the source. On the other hand, a smaller particle, because of its lower size, can go up to a farther distance because it can be suspended in the atmosphere for a large amount of time. Okay, so okay. Now next come is the transformation. So what is transformation? Transformation is when a particle is converted into something else. So this is what I discussed here, that sometimes instead of directly a particle, okay, in directly the emission cannot be in the form of particle, it can be in the form of gases. Okay, but a gases cannot deposit. Okay, it cannot fall on a surface. So for it to fall on a surface or to deposit on a surface, it has to convert into something, right? It has to convert into a particle, and that is what transformation is. That when gases are released, they convert into something and they then deposit or then affect, right? So for example, SO2 and NO2 leads to acid rain. These VOCs combine with the other oxidant in the atmosphere and leads to a compound which we call as which we call as brown carbon aerosol. Now, the third thing that can happen to these emittent or these pollutant in the atmosphere is removal. Okay, so removal is that how they will be removed from the atmosphere. When it comes to removal, there are two methods which we majorly think about or discuss. Okay, so these two methods are dry deposition and wet deposition. So deposition, as the term suggests, it means that the particles or whatever pollutant are released in the atmosphere, they have to deposit, right? Now they can deposit, they can have dry deposition. When you say dry deposition, it means that the deposition is solely because of the wind. Okay, that for example, let's say in a place it's a very windy region, so whatever the emission is here, those wind will carry that emission to another place. Okay, because this location is very windy. But let's say these wind carry the particle, take it into another place or another let's say a locality or a city, and there the wind speed is very less, and hence as the wind speed decreases in a particular place, the particles will deposit itself. Okay, another is wet deposition. Wet deposition means that they deposit due to rain or snow or hails, the hailstorm. So what happen is that there is gases. For example, I gave example of acid rain. So these gases are in the atmosphere. When their concentration increase or when their reactions, they found oxidant and their reaction proceed, they they deposit in the form of acid rains. Okay, and these particles directly combine with the rain droplets or attach themselves to the rain droplets and fall. And same for the snow. Okay, and when I say these particles, I consider them, I am like, for example, black carbon and brown carbon particles. Okay, So removal is that they settle. So how they settle, or how they can scavenged by dry and wet deposition. Adsorption, in the same way, adsorption is nothing but someone attaching itself on someone else, on another pollutant surface. So it's same when these gases, these VOCs attach themselves to a particle, or absorbed on a, or adsorb themselves on a particle, and then undergo this wet or dry or wet deposition. That is a method of removal. Okay. And then we see, when we see sink, we see that how uh, these particles, or how the whole atmosphere is responsive towards the ecosystem. Okay. So this is the whole source and sink relationship, that there are multiple sources. There is natural as well as man-made sources. There is primary emission, where directly emitted in the form of particle, or there can be secondary emission, where it can be emission in the form of gases, which later convert into the particles. And okay. And then there is different state in the atmosphere, for example dispersion, transformation, as well as removal of these pollutants. And then we look at how these pollutants, their emission as well as their removal, affect the ecosystem on a whole. Okay. Now, another question is about, as an adult, how much air is required in a for a human body. So the answer is about 15 meter cube, or about 15 kg, which is actually 10 times or 20 times more than the amount of food or water we require, our body require. And that is why it is very important component, and to take care of. Okay. So when we say about, one thing I want to say is that when we look at air pollution, right, we never there are few things which affect you directly. Okay. There are few disease which happen very directly and can affect you. But when it comes to air pollution, it kills you slowly, because you are exposing yourself every day to a large number of pollutant. You are breathing 24 hours. Even when you are sleeping, you are breathing. So the pollutant around you are 24-hour affecting your body. That is why it's very important to keep your surrounding, to keep the environment free of these air pollutant. Because, and the very important thing is that some of these pollutants can actually have a lifetime of about a week or so. So if we stop emitting these pollutants now, some of these particulate matter, for example black carbon, brown carbon, they can be actually be gone from the atmosphere within a week, or within 2 weeks. On the other hand, some pollutant like methane, carbon monoxide, carbon dioxide, they are prolonged. So we have to start reducing our emissions now if we want to reduce these gases, or the emission of these gases, right? Now we move towards the another question. What are the major factors that affect the human health? Okay. The for the from the air pollution. Okay. Is it audible now? Hello? Hello? Okay, 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 okay. Thank you. Um, okay. So when it comes to human health, okay. So one of the third, I think third lecture is about the effect of air pollution on human health, right? So 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 what are the different factors? First is the nature of the pollutant. As I said, that some pollutant have a very short lifespan, and they can be removed from the atmosphere. Hello. Okay, 1 second. Ruchita, other people are able, like, they can hear me, so just see once again. Okay. Okay, so nature of pollutant, because some pollutant can have a very short lifespan and can affect the can be removed from the atmosphere easily, and some have a very prolonged lifespan and affect can affect like in long term. For example, CO2, carbon monoxide, right? So the nature of pollutant has an effect on the is one of the factor for the human health. Another is concentration. Okay, so for example, in near an industry, okay, where the concentration of these pollutants are very high, the population around that industry has very high risk of having pulmonary or lung diseases or nasal diseases. On the other hand, a far off population will not be that much affected, but some concentration again is prolonged, right? So for example, CO2 is being emitted since past, and is still being emitted and is still affecting us, right? So these pollutants which have longer time span, their concentration also accumulate over a period of time, right? So uh, so the lifespan of a component also affect the concentration of that pollutant. Next is the duration of the exposure. Next is the duration of the um, duration of the exposure. For example, again, I will give you an example of an industry, that people who work in coal mines, or let's say in these polluted industries, they are in more risk of getting affected by the pulmonary or lung diseases. On the other hand, people who works in offices have less chance, even though still there are other pollutant in the office region as well. But the people who work in coal mines or these lead factories or rubber factories, they have longer duration of exposure to a particular pollutant, right? Next is state of the health of receptor. Again, state of health means that if a person is healthy, then less pollution or like little pollution will not affect a large a large duration of exposure will affect. If the health is very weak, then even a little bit of smoke from the vehicle also could affect. And last is the age. So the two major age group that are most severely affected by or can be affected by this is children's, जो like kids who are less than 10 years old, and adults which are like about 50, okay, more than 50, so just a second, uh, adults who are above, let's say, 55 or 60, okay. Another so these are some of the factors which can affect the human health. Now we look into this question, which is another question, which is about the relation between the severity and the proportion of people affected by the air pollution pyramid. Okay, so severity is that how severe situation become, like how severe is the impact of a particular of any air pollutant, and proportion of people is how many people are getting affected. So this triangle is being shared. Okay, so what is the relation? The relation is that it's inverse to each other, that we always see that a large population is affected, uh, because a large population is getting exposed to the air pollutant every day. But some of them have longer duration of exposure because they works in mines or factories or industries, and some works in, let's say, clinics or hospitals or places like that. So again, a demarcation happened. So exposure is happening in both ways, but in one particular population the exposure is relatively higher compared to the another. Okay, next is physiological changes and clinical effect. Again, it depends on the health of a receptor. Okay, a healthy individual, even if he or she works in an industry or a factory, would get ill at later stage compared to an unhealthy individual. Okay, so that is also a factor. Another is symptom of illness and use of medication. That what are these symptoms, and if those symptoms can be uh, one second. Okay, and the I hope it's visible. Just a second. You guys can see the screen, right? This is okay. Then it's about the number of healthcare attendants, or primary or emergency healthcare attendants. For example, the people who are not very well to do financially, or people who belong to who are workers and they cannot afford a high end medical facility, are more prone to getting die or like getting affected by the disease compared to people who can afford a good hospital, right? Or who can pay these hospital bills. And eventually the last is the death. So this is an inverse relation, because the exposure is higher but the severity is actually lower. Okay, the number of deaths are low, but if you count these number of deaths just because of air pollution, just because of a primary factor which we breathe every single day 24 hour, it sums up to be a very large number, because these deaths are not because of any natural calamity or anything. It is happening because of something that we are inhaling 24 hours in every day. Okay, so this is the answer. Now we move towards the other question. So this is, which pollutant is silent killer? So carbon monoxide is called as silent killer. The reason is that this is neither it has any taste nor it has any odor. Okay, so neither you can taste it nor you can smell it. Now how will you see that if there is, let's say, a carbon monoxide explosion, or somewhere there is a leakage of carbon monoxide? You can't even guess it, because you can't taste it, you can't smell it. Okay, so that is why it is called as silent killer, because you cannot know if there is any leakage of carbon monoxide near you. Okay, now another question is the major events in the history which are due to the sulfur dioxide pollution. So we know the sulfur dioxide can leads to formation of sulfuric acid H2SO4, which can cause acid rain. But these sulfur dioxide also can make the SO3, which is another sulfur product. And this SO2 pollution is actually one of the reason of London smog and New York smog in 1952 and 66. These two events are also discussed in the lectures. and and because of in both these scenarios, not just the not just humans, but also a lot of animals as well as plants died because of this sulfur or acid rain, or these smoke clouds because of this sulfur dioxide. Okay, so these are the two events, major history event that I think you should remember about the sulfur dioxide pollution. Now, what are the source of tropospheric ozone? Okay. Now, this is, I believe, this is a very important question, because when we look at ozone, we see that ozone means stratosphere. Okay, because this is what we are told, that in stratosphere there is ozone which save us from UV radiations, and which does not let UV rays pass to the earth, and hence we are safe from skin cancer and all of these skin diseases. But the thing is that this stratosphere is very important in this ozone is very important in stratosphere. Okay, but when it comes to troposphere, we don't need ozone in troposphere. Most of the our atmosphere, about 80% of the atmosphere lies in troposphere. Okay, our major gases are in atmosphere. uh, we Whatever we breathe, everything comes from atmosphere. These clouds are in atmosphere. Rain comes from rain also comes from troposphere. So we don't need ozone in the troposphere, because when it comes to troposphere, ozone is really bad. It is another pollutant. It is considered another pollutant and can have a harmful effect on the human as well as plant and animals. Now, since ozone can only be found in stratosphere, then the question arises that how this ozone come to the troposphere. Now, the answer lies in the NOx and VOC's chemistry. Okay, so the, we know that when we look at the entire day, okay, so this is day, this is night, let's say 24 hour, we see that the NOx increases towards the night. Okay, but the ozone increases in the midday. Now, this is ozone, this is NOx. The thing is that this NOx or NO2 can undergo reaction in the atmosphere, which leads to, can undergo reaction with these VOCs, let's say, and form and release this singular O. Okay, this single oxygen atom can react with the oxygen present in the troposphere and gives this ozone. Okay, now, but the thing is that this NOx is high during the night, but the ozone concentration is highest towards the midday, because ozone formation is actually a sunlight enhanced reaction. It can only happen when there is sunlight. So why it happen is, so NOx or the NO2 is released during the night. Okay, it can comes from both vehicles as well as from the plants as well. Now, what happen is, towards the night, uh, there is a 1 kilometer height layer, okay, which we call as boundary layer height, which is about approximately 1 kilometer from the surface. So this boundary layer actually is where you see a thick uh, cloud of all these gases and these pollutant, which is just 1 kilometer above the surface. Now, towards the night, because of temperature decrease, okay, and pollutant increase, this boundary layer height also decreases. Okay, so this boundary layer height decreases, which leads to the accumulation of these NOx, and hence formation of this what, oxygen atom. Now, since this oxygen atom is not going anywhere, is still present in the atmosphere, the next morning when the sun comes up, this oxygen atom react with the oxygen in the presence of sunlight and gives this ozone, which is a uh, one of the pollutant in the troposphere. It acts as a pollutant in the troposphere. Okay. Now, okay, another question is, what is the relation between particle size and deposition position in the human body? Okay. So we know that in human body there is a nasal passage. Okay. Then the lungs come, mm, and in lungs there is these bronchi and alveoli, right? Now, when it comes to uh, particles, we know that the larger the particle, the farthest it can go because of its size, right? So, if a particle is large, it can enter or it can be blocked by the nasal hairs or nasal mucus itself. If it's smaller, it goes up to this larynx or trachea. Then, if it's again smaller than that, it reaches the bronchi, which is these pipe-like structure which carries the air. And then, if the particle is smallest, it reach these alveoli, and if it reaches the alveoli, it has the most harmful effect on your body. Okay, because alveoli are also called as the airbag of the lungs. Okay, so these tiny looking the grapes looking thing are basically can expand and take a large amount of air and can help in breathing, right? So the smallest a particle, it can reach up to the up to these alveoli and can have higher health effect compared to a larger particle. For example, if you look at PM, which is particulate matter, 10 to 1, let's say. Okay, so a 10 micrometer particle can reach, let's say, up to this larynx region, but a 1 micrometer particle can reach near the end or even in the alveoli and is harmful. That is why currently people are, or the scientists are more inclined towards studying this PM1 or PM less than 1, particulate matter less than 1, because these have higher or larger health effect on our body compared to the PM10, because it is blocked by our nasal passage itself. Okay, so this is one thing, that smaller the particle, the farthest it will be deposited, and higher it and larger will be its effect on the human body. Okay. Uh, that is why one of the thing is that when people drink sorry smoke these cigarettes, right? So in cigarettes we see that towards the end there is a filter. The reason of that filter is because these cigarette have very fine particles that can actually reach up to these alveoli and can clog it and can slow the breathing process, right? And that is what happened, that on a prolonged smoking your lungs become bad. Why? Because these thin particle, less than 1 micrometer particles from the cigarette, start getting deposited on these alveoli and reduces the breathing capacity. Okay, now the next question is, what are the ways in which a pollutant can enter any plant, animal or human? Now, we mostly see that Ruchita, everyone is able to hear me. So that is why I'm saying that just try that what is happening at your end. Okay. So, so when we come to air, generally what we think about is that okay, it's air, the higher chances that we are inhaling it, right? So the maximum pollution is because of inhalation. But that is not the only way any pollutant can enter a, a plant or animal or a human. Okay, inhalation means that you are inhaling something via your nose. Okay, that is one way, no doubt. Another is ingestion, which is one of the way the animals are getting affected. Okay, that is also discussed in the lectures, that when these particles are getting deposited on these fodder, okay, on the plants, these plants are getting eaten by the animals, and hence one of the way the animals are getting affected or uh, is due to, sorry, okay, one of the ways these animals are getting affected by the air pollution is because of ingestion of the plants or of the fodder that actually have the deposition of air pollutant. Okay, now now the final thing is thermal contact. Now generally it does not happen, sorry, ingestion, one of the way, another way of ingestion is that if in a region there is lot of acid rain, okay, then the rivers which are actually filled by acid rain, or in which there is lot of deposition from the acid rain, in those river the fishes, the planktons, all of these die. So that is another way the air pollution can enter via ingestion. Now thermal contact is valid for other pollutant, but for air pollution it is not that valid, that if let's say a particle or a air pollutant enter your skin or fall on your skin, it will enter your skin because it's not that harmful. But dermal contact or the contact with the skin is another way any pollutant can enter a body. Okay, now this is the final one. Okay, now in the lectures the plant health is also discussed. So my next question is about the same. It is that the degree of injury against air pollution for plants, okay, depends on what factors. Okay, so this is the degree of injury, that how much a plant will be affected by by air pollution. It depends on two things. Okay, that is concentration and time. Concentration and time. So why I'm saying, oh, so why just these two things? Because now if we look at plants, these particles can enter plant either directly, can affect plant directly as well as indirectly. Okay, so directly means that it can enter, it can fall on the surface, cause some issues with the stomata, with the cellulose, all of that. Indirectly it can enter via the soil system. Okay, it can enter via root and all these xylem and phloem structures, and it can affect a plant uh, via that. Okay, now concentration, why? Because if any pollutant is in lower concentration, even if a plant is in a let's say, okay, so a plants near industries are more prone to, like, we don't generally find plants near industries. Okay, or even if you find plants, they generally are like almost on their verge of dying. Okay, because there because of the concentration of pollutant coming from the industries. Another is time, that sometimes a plant can be in a location which is not near a factory or an industry or a coal mine. It can be, let's say, a roadside. Okay, now over time, because a roadside plant is getting exposed to pollution every single day, it can over time, let's say 20, 30, 40 years later, you will start seeing effects of the pollution on these plants. Now how it can, so these effects can also be like small or can be big. For example, either they can be no effect. Next is nutritional value change. Okay, so for example, these vegetable grown near a polluted region will have less nutritional value compared to an organic vegetable. That is what people these days people are saying, organic vegetable and organic food. So because they remove these pesticides and all of that from the soil system, and hence maintain the nutritional value. Next is biochemical alteration. That is, there is some alteration inside the plants, or there you can see some yellow spots, some dark brown spots on the plant. Okay, and sometimes you see the physiological that is a plant will start like it start bending or something, or it's you can see like shriveling. That is what we call that. These uh, these leaves start to curl and all of that, and eventually it will die because of these different plant diseases like chlorosis and flecking, all of that. Okay, so the two things which matter is how much is the concentration of the pollutant and how much a plant can be is exposed. A concentration can be very high, but the exposure time, if exposure time is very low, then it will have no effect on the plant. On the other hand, concentration can be very low, but if the plant is exposed to it for a very long time, 30, 40, 50 years, it will start showing the effect of the air pollution. Okay, now next is the what are the type of air pollution related damage to the buildings. So in the, I think in the last lecture of the week 1, sir discuss about the damages to the structures and buildings. So one of the visible example that we see uh, about the air pollution damage to the building is Taj Mahal. Everyone knows that it is supposed to be white, but currently it is going towards the yellowish version of it. So now, when it comes to building, some materials can get affected, can have more effect, and some material can have less effect, right? So, it also, so the effect on the buildings also depend on the type of like on the material of the building. Okay, for example, the Taj Mahal have more effect of these SO2 and NO2 pollution. On the other hand, the red fort, okay, has lesser effect because it is made of red sandstone compared to marble in Taj Mahal, right? So these two are same building structures, but because their materials are different, they have different effect. Okay, so we look at what are the damages. First is discoloration. So as I said, that Taj Mahal is the correct example, that over time, because of the exposure towards the air pollution or air pollutant, sorry, these they can get affected. So because of air pollution, the color can start change, and in some material we see it very clearly, in others we don't. Okay, for example, rusting of iron. Okay, if you take an iron, let it like let it rest on your terrace for like for days or months, you will see that it start rusting. Even if it's not raining, it will start rusting. Okay, so that is one. Another is material loss. Of course, iron is again an example, because of rusting, because of oxidizing of the iron, all the upper layer get damaged and the material is being lost. Third is black crust formation, because of one of the thing is that these black flakes start forming around the building. Uh, fourth is structural failure. So how structural failure occurs is that if you know this method called freeze and thaw. So what freeze and thaw does is that sometimes when the temperature is high, when the temperature is very low, the structure or the building material will start to contract, okay, because of the formation of because of freezing of the vapors, or because of freezing of the water vapors in the pores when it comes. But over time, when the sun arrives, these cracks, the air, sorry, the snow start evaporating, these cracks start building up, and then in this sunlight the cracks start developing in a structure, okay. So that is structural failure. Because of this, the structure can also like get damaged. Another example is that when you see like the paint in the house, especially the outside paint towards the which is more exposed toward this the air, for example on the terrace or on near the front gate of your house, all of these the wall which you make of cement, they actually over time, because of this freeze and thaw, will start like crumbling down. Okay, that is one of the example of structural failure. It cannot happen on a very large scale. Okay, it's not like that today it start getting like exposed to air pollution and next day it will break apart. No, but you start seeing the crumbs coming out of the building here and there. Okay, next is the abrasion action. Abrasion is nothing that because of the friction, uh, these like flakes sort of structures start forming. It generally happen for the paint, that if you have paint it start crumbling because of the air pollution. Okay, hello, it's audible, right? Hello, I'm audible, right? Okay, okay. So these are some of the ways it can get affect the the air pollution can affect the buildings. Now, the meteorology or the meteorology can also affect the structures. The example are humidity, temperature, and wind. So, for example, wind, because if there is, it's the easiest example of wind I would say is sand dunes. Okay, that if because of wind these sand dunes keep on moving. So if the wind is high, the structures become very unstable. Okay, temperature, the example is freeze and thaw, that if the temperature is very low, the materials start to get constrict, and when as the temperature increases, sunlight comes, the materials start expanding and hence start forming these cracks. Humidity, because again water vapor play a very important role in all of these damages. For example corrosion, for example for these structural failure. It also, because if there is humidity in the air, then it actually of course it enhances the temperature freeze and thaw reaction, but on itself it it first it act for the corrosion, and it reaches the pore surface of the structure, and hence can can be one of the medium of the deposition of these particles in the pores of these structures. Okay, so metrology is basically enhance the damages done to the buildings by this air pollution. Okay, they are not the only factor, but what they do is they enhances these effects. Now the last is about the farm animal susceptibility. So lot of in the lectures, lot of air pollutant effect on different animals and birds and insect were discussed. Now they are affected by all these major pollutants. For example, SO2 is there, NO2 is there, ozone is there, particulate matter is there. But one of the thing is that farm animals are mostly susceptible to the fluoride. Okay, because of fluoride toxicosis, they can have effects on their teeth, on their bones, and it's very harmful for them. Okay, so currently I have made only these questions. I will share the slide as well with you guys. It is supposed to be a 2-hour lecture, but since my question ends and this is my first lecture, I will try to increase the number of question next time. But for today, we'll end here. And if you guys have any questions, you can ask me. And yeah, okay, Dipali, yes. So tomorrow I will upload this class as well as the slide, and the NPTEL will share the slide and the lecture and the video, everything to you. So you don't have to worry. This video will be the lectures will be shared with you. Okay. So if you have any question, you can ask. Otherwise, for today we are done, and for next time I will okay, problem question. No, currently we are not supposed to. I don't think we are supposed to give you problem question. We are supposed to just find the questions that we think are relevant and explain them to you. And I hope that from next class I will increase the number of questions, and we'll stay for I think 2 hours in the next class. Okay. If you don't have any questions, you can leave. If you have any questions, you can ask. Thank you for today.